Good afternoon. This video is going to cover more information on independent samples t-tests, a few of the slightly more advanced than just the basic running through the SPSS commands. So we are going to include both SPSS and some additional explanations to look at independent samples t-tests and make interpretations for one-tailed hypotheses regarding the test of homogeneity of difference and effect size. So first of all, I'll set the context for the data we're going to look at. This relates to a quasi-experimental design. That means the design that does not have random assignment to groups for something called the Principal School Initiative. And the Principal School Initiative, or PSI, has a purpose of improving principal effectiveness by distribution of decision-making and teacher autonomy. So allowing multiple people in the school to have decision-making and choice so that the principal can be more effective at their job. We have non-random assignment to whether or not a school participates in the initiative or not. And this sample that we're going to look at only has 10 teachers per school condition. The school condition is coded 1 if it's a principal school initiative school, and 2 if it is a non-PSI school. We've got 3 dependent measures, all of which were completed in the form of surveys by the 10 teachers, or by the total N of 20. There's a measure on teacher perception of curricular autonomy, general teaching autonomy. So those are how much teachers have choice in curriculum and general teaching decisions. And I misspelled, I'm sorry, principal effectiveness survey. Hate to misspell things. I will fix that quickly. Okay, so here we have sample items from the, this is the curricular autonomy scale and part of the general teaching autonomy scale. And so just as you can see, these are some information that you don't need to know, the numerical information. I just wanted to see you to see what some items are like. Curricular autonomy has to do with, for instance, I have little say over the content and skills that are selecting, goals and objectives, what I teach, the materials I use, and so on. Whereas general teaching has more about standards of behavior, scheduling, and teaching approaches. So those are just some samples of the sorts of things that were asked in this study. So what we're going to say is that this particular researcher had a hypothesis that there would be improvement due to the PSI or related to the PSI initiative in all 3 of these dependent measures. And so these are one-tailed tests, and the researcher has set a alpha level of 0.05. So the null hypothesis would be that mu is greater than or equal to 0, and the alternative hypothesis would be, and that's actually, I'm sorry, mu1 minus mu2 would be greater than or equal to 0. That's a no difference. And the alternative, which is what you want to support, is that mu1 minus mu2, mu1 being the population for the PSI sample, would be greater than 0. I should have written those down. Mu1 minus mu2, null is less than or equal to 0, mu1 minus mu2 is greater than 0. That's the way it should be stated. So again, those are the sample items, and now we're going to look at the data. Okay, so here are our data. We're in variable view. The condition is which group was assigned. It's coded 1 if the group was the PSI, Principal School Initiative, and 2 if it's not the Principal School Initiative. And we have the 3 dependent measures. Auton C is curricular autonomy, Auton T is teaching autonomy, and PRIN-PER PERC is perception of the principals. So just very quickly, I'm going to run some descriptive statistics. That's always a good idea. And I'm just going to take a look at all 3 of these measured variables in terms of their means, their medians, their standard deviation, and their minimum and their maximum. I'm checking the minimum and maximum to see if there are any implausible values. I know these things were scored on a scale of 1 to 7. So what I see is I have 20 people total in the study. The mean for each, for the 2 autonomies is 4.6, 4.5. Principal perception is 2.93. The medians are some fairly close to the means. If I were being thorough, I'd look at the distributions, but this is material has already been covered in another video. And the standard deviations are the standard deviations. What I was interested in was finding the whether or not there are any implausible values. I think as I described it, the value for principal perception is of 0.92 is implausible because I said that the lower limit was 1. However, I forgot that the lower limit on that scale, which is a different scale, is 0 to 6. My apologies for mistakes on this presentation as usual, but I've had to make a lot of the presentations and they're not all as well prepared as they could be. And now that I think of it, yeah, you're seeing. Okay, so going back to data. Second, making sure that you can see what I think you can see. What we want to do is we want to run independent samples t-tests on each of these 3 variables. So we can actually do that all at the same time. So we go to Analyze, Compare Means, Independent Samples t-tests. We're independent samples because we have 2 groups and the 2 groups of teachers are not related to each other. They're, for instance, not in the same school. So I'm going to reset this. We have the curricular autonomy, the teacher autonomy, teaching autonomy, and the perception of principals. To refresh, since I have stated some things that are incorrect. Curricular autonomy and teaching autonomy are measured on scales from 1 to 7, and principal perception is measured on a scale from 0 to 6. We need to know our grouping variables, so the variable that distinguishes the 2 groups we want to compare, and that is named condition. And the 2 groups for condition have been coded as 1 and 2. So you have to put in the proper code value, and you want to put them in the proper order. So when you have a 2-tailed hypothesis, order matters because it will affect whether you have a positive or a negative result. So because my hypothesis is of better scores for the PSI group, I want the PSI group to come first, so that if it has larger scores, the result will be positive, because my mu alternative is that mu1 minus mu2 is greater than 0. So I continue. There's no particular, these two options matter if you have, if you're making multiple analyses like we are, but they have different numbers of cases. In this data set, we have complete cases for all variables. And you can have confidence intervals of different values that you can arrange there. So we're going to continue, and we're going to tell the program that it's okay to continue. So the first thing we see is are the descriptive statistics for each dependent measure. And we would report those in a table. Because n is constant, you don't have to report that as a separate column, and you don't usually report the standard error of the mean per group, but you would report the mean and standard deviation, and you'd probably report it per group rather than overall. What you might do is you might report it per group and then also total. So there are a variety of ways that you can do that. And I, as time allows, I will illustrate that in a separate video. So here is where things get interesting. And I'm going to start by skipping over the Levene's test for equality of variances, which is really where I should start. But instead, I'm going to skip straight to our t-values and their significance. And you should remember that our hypotheses are one-tailed. So what it looks like at the surface is that you look at sig, two-tailed. Sig means the probability of the value being beyond the 1 minus, how do I say this? The probability in the tail, or tails, but it's always two-tailed, as you see here. So the probability of the value in the tail. So you see 0.059, and you think, well, that I have a hypothesis with an alpha of 0.05 that doesn't fall below 0.05, so I don't reject the hypothesis, the null hypothesis, I retain it. And you see 0.034 with autonomy teaching, and you say, oh, that's below 0.05, so I reject the null hypothesis in this case. And for principal perception, you see 0.512, and you say I retain the null hypothesis in that case. This, however, would be correct for a one-tailed test, but SPSS is reporting a two-tailed test. So I'm going to change my share back here. Okay, so I've got a couple graphics on here that are based on the unit normal or Z distribution, but the logic for t-tests is the same, and we're talking one-tailed test. So SPSS gives you this SIG, and it's the exact probability of a value exceeding the value under the null. So it's the probability of a value in the tails. Now, that assumes, as I said, a two-tailed test. So it's the combined probability over both tails with alpha of 0.05. Well, when the SIG is 0.05, that means 0.025 in each tail. So you'll have a significant result when that is less than or equal to 0.05. And that's kind of like what you're used to with a two-tailed test. It reads, it maps onto the logic of a two-tailed test perfectly well. But for a one-tailed test, this is on the right, you're not distributing over two tails. SPSS doesn't know that. SPSS treats all t-tests as two-tailed. So with the shaded value at the bottom on the right hand, you see that this is 5% in the tail, which is the area of significance for a one-tailed test. But SPSS would report that as 0.10, not 0.05, or 10%, not 5%. And that's because it's counting the identical symmetrical region over here. So it thinks that if you've got 5% over here, you also have it over here, and it adds them up and comes up with 0.10. So you have to correct that oversight in the SPSS program, that there should be an option to choose one-tailed, two-tailed. There isn't. So what you have to do is, if you see, for instance, a significance level of 0.08, and that what that means is 0.04 per tail. And if you're only looking at one tail, what you do is you divide the 0.08 by 2. So for a one-tailed test, you divide the value under the SIG column by 2 and compare it to your alpha. So back to the data. What we see here for the autonomy curricular is that we have a two-tailed SIG of 0.059, but for the one-tailed test, which is that the PSI teachers have higher curricular autonomy than the non-PSI teachers, what we should interpret that as is 0.02 9.5. No, if I've already got a point in there, I can't put it into 0.0295. Maybe I already said that. The t-value is unaffected by that, so that because that's the obtained t-statistic, SPSS does not report a critical t-statistic. The degrees of freedom aren't affected. The mean difference is the difference between condition 1 and condition 2. You can actually recreate all of these things. You can recreate the standard error of the difference from the standard deviations and the sample size. I find it personally a good exercise to try to recreate these values up here from the these are the values that you can recreate from your own calculations. You only have 20 values in the calculations, so you could do this data set. And it might not be a bad thing for you to try it. You could even do it based only on these summary statistics. And then you could recreate this row of responses. And I actually would recommend that as an exercise, and I do it frequently, or at least I estimate it in my head. So, so this actually is going to be significant. You're going to divide it by 2, and that will give you below alpha of 0.05. The confidence interval is provided. The confidence interval would have to be changed. And you could hand calculate that with the appropriate t-statistic, or you could set it differently in the command in SPSS to do it. So this is not the right confidence interval. And one way you can tell that is because it includes the 0 value, where you know actually with the corrected significance level that it is statistically significant. Okay, so this is all, what shall I say? This is an annoying characteristic in SPSS. You would think it would be very simple for them to put in an option, is it one-tailed or two-tailed? For decades, they haven't done this. And but you do need to keep track of it, because if you're a researcher and you have a statistically significant result with a one-tailed test, you don't want to ignore it. Okay, so I'm going to now continue to the next part of the analysis of these data points. Which is having to do with the test of equality of variances. So one of the assumptions is that variances in 2 groups for the purpose of the inferential t-test are equal. That's also known as the homogeneity of variances. Violating this assumption can lead to either type 1 or type 2 errors of inference. So that means that your interpretations would be incorrect, and it would be due to a statistical artifact or violation of assumptions. That's basically, besides just reading your output wrong, which you can do with that one-tailed test, violating assumptions is a major reason to make statistical errors. So you don't want to do that. Type 1 and type 2 errors, by the way, are covered in another video on this playlist. So you need to test the assumption to find out whether your between group variances are equal. And just a note here, there is really in the world of probability and random error, there's no such thing as actually equal. It's within the bounds of what you tolerate for error. So just like any other test, you have an alpha level. However, and well, this is not quite the however part, in SPSS, the default is Levine's test. And there are other tests which are described in the textbook, but Levine is provided in SPSS. So in the case of an assumption, Levine provides what's called an F statistic, which is covered later, but it doesn't matter what statistic it is for the time being. What you want is for it to have a significance level. That's written as sig, but it's written under the F test, greater than 0.05. So usually you've been looking, if your alpha is 0.05 at less than 0.05. If your alpha is 0.05 for a one-tailed test, then you'd look in the sig for less than 0.10. But it's always something analogous to your alpha level. If your alpha is 0.01, you'd look for something less than 0.01. When you're testing an assumption, you want the sig level to be greater than alpha of 0.05. And basically it's always 0.05. You don't really fiddle or change your alpha level. There's no such thing as a two-tailed test. It's just 0.05. You want to be greater because you want to retain the null hypothesis that variances are equal. It's an assumption that they're equal, you want to support the assumption, which means retaining the null, which means having a significance level greater than 0.05. If it's less than 0.05, you violated the assumption. Back to the second bullet, you can lead to errors of inference. If you violate the assumption, SPSS by default with a t-test of independent sample means provides something called the Welch's t-test. And that's an alternative test with adjustments to the formulas that you can use to report the result of the comparison instead of the regular t-test when the assumption is violated. The t-test is said to be robust to violations, sorry for the typo, in the assumption of homogeneity of variances, meaning that differences in variances, even if they're statistically significant, will generally not change the probability of the outcome. Now that's generally. And if you don't meet the assumption of the variance, then you have that problem. This is a reason to have equal sample sizes because the probability of not meeting the assumption of variances is greater when sample sizes are different. So going back to our output, we want to examine the results of Levine's test of equality of variances. And so you see the column with the F statistic. Note that just kind of know what you want to look at. The whole business with the t-test and whether or not you have statistically significant results is to the right of the F-test, which is reported first. And really that's because if you see a significant result in this column, you're not really supposed to go forward. So we're good. The significance level of the assumption is above 0.05 for the test of autonomy and curricular. The significance of the assumption is also retained for the test for equality of variances in teaching autonomy, but it is not. It is less than 0.05. So the assumption of equality of variances is not met. And if anything, you have to proceed carefully. So also note these rows. One row on the test is for when the assumption is met. One row on each test is for when the assumption is not met. So if you had something less than 0.05 here, and this is called the Welch's T. And what is the adjustment here is in the degrees of freedom. And usually if you don't have a small departure from the assumption, your generally results will be the same. They'll be different, but they'll be similar, not the same, I'm sorry, similar. However, in this case, we have a violation of assumption. You should look at this row, the row where the assumption has not been upheld. Sorry for the bad writing. And you see that the result of the t-test is not significant. It is not below 0.05, which because these are all one-tailed tests would show up as 0.10 in the significance column. Now, that's true actually when you assume equal variances here, but the probability values are quite different. And so this can make quite a difference, especially if you're like on the borderline of a significant difference. So that's the test for equality of variances. You should always check it with an independent samples t-test. And now going back to our last point. We have effect size. So effect size is a way of expressing how large a difference there is between means. We're only going to be looking for now at between mean differences, which is what corresponds to the independent samples t-test. So what is the magnitude of the difference between the two independent sample means, or the two groups? The null hypothesis significance test only tells you, is the difference beyond the bounds of chance alone, beyond your alpha set bounds of chance alone? It does not tell you, if it is unlikely due to chance, how big is it? So we use something called Cohen's D after Cohen, Jacob Cohen, who is responsible for quite a bit of statistics in applied social sciences. So you'll probably run into his name again in the research methods class. And he came up with this measure of what they call effect size. So what it is it's a standardized measure of the difference between two sample means. And he set these things called Cohen's rules of thumb, where the magnitude of a difference between two independent sample means is interpreted by the magnitude of the value of D, with a small effect being considered below 0.2, a moderate effect between 0.2 and 0.8, and a large effect above 0.8. These are rules of thumb. They should not be taken as law. And many people, myself included, kind of wish they had never come into existence. However, many people, myself included, report them. But in terms of interpretability, what you should be aware, the result of a D-test will be in standard deviation units. So if you have a D of 0.05, you say that's a moderate effect, probably. You more meaningfully can say that the difference between the two groups is approximately half a standard deviation. So, you know, if you have an intervention that changes people in their something or other by half a standard deviation or a full standard deviation, that's a fairly powerful effect. That's like if you think of the standard deviation of the SAT for a single test is 100 points, that's like on average shifting people 50 points, like from a 700 on verbal to a 750. That's a lot. So the formula for the D statistic is given up here above. The numerator, as usual for one of these statistics, is easy. It's just the mean difference. The denominator is a new term unless you have read the slides. It's not a video on doing independent sample mean tests with unequal group sizes. So the value in the denominator, S squared P, is pooled variance between the two groups. And the square root of that is the pooled standard deviation. The second formula is only used when you have a control group, in which case you, for the D, you can just use the standard deviation of the control group. You should always report what kind of effect size you're using. So you can just say literally, for this effect size, D was calculated with the standard deviation of the control group in the denominator. The assumption is that it's the pooled standard deviation, which is the formula on the left. So we're going to work out effect size per curricular autonomy, because I'm sure you'll be delighted to learn that it's not in SPSS. So first, we're going to go back and, well, first we're just going to, now we're going to go back and look at the data. Look at the output. This output gives us everything we need. And what you need for the effect size, you don't need any t statistic. You should only do an effect size if the t is statistically significant, because like, why talk about how large an effect is unless you have reason to believe it's not likely due to chance. If it's just a chance effect, who cares how big it is? But you should use an effect size when you have rejected the null hypothesis. So what you need is, you need the sample size, the size per group, the mean, and the standard deviation for each group. That's what you need. So to do, I believe we're going to do, which one are we going to do? Curricular autonomy. We need these groups: mean, mean, standard deviation, n of 10, n of 10. So going back to the slides, D, Cohen's D, is one mean minus the other. Very simple. 5.23 minus 3.72. I rounded these off for presentation. Sometimes it's useful to keep them to the most available digits until the final step. It'll alter the results slightly. And then you have the square root of the pooled variance. So this is written out slightly more. So I put the numbers in it here. But now, what is the pooled variance? It is the variance of the first group. Sorry, this should be the variance of